Ramzi is the CTO of EyeEm. So before we get started and to put this a little bit into context, Ramzi, why don't you say a few words about EyeEm? So,
yeah, sure. First of all, thanks for having me, and I'm really looking forward to this. EyeEm is a company that we started 8 years ago, 8 years ago, from a passion for photography. So it's a platform and a marketplace for amateur photographers, initially using apps, but now apps and web and everything else. We help photographers that sort of want to become better, to learn, to connect, to interact, to get published, to get exhibited. We organize the world's largest photography competition and exhibition every year. And at some point we started licensing the content and connecting them to really large brands and agencies and corporates that want to license sort of authentic imagery or want to even source content from all over the world without having to hire big crews to travel everywhere. And this is kind of a, it's a really, I think, authentic approach to business, because we want to empower photographers, and we decided from early on that the way to do that is to basically succeed together with them. And obviously we're not here to talk about the beautiful community and the marketplace. We started investing very heavily in machine learning 5-6 years ago, built up a pretty solid large team of computer vision researchers for two purposes. One of them was we needed to understand what was in the photos, so we needed to build deep learning models that can understand and be able to classify and tag images. And the other, which was the more ambitious one, I think, was we wanted to understand quality, because not every photo is great, not every photo is beautiful, but we wanted to teach machines to understand what is beautiful, what isn't, what is commercially viable, what isn't, and we've done quite a bit of work in that area, which I guess we'll talk about later.
So I mean, you've been in the field, as you mentioned, for a while. So how have your views changed, specifically on machine learning, over the years?
Funnily enough, when we were just starting out, even me as a technical guy was saying, we can't automate this, and we won't be able to for now. I think everyone, when you talk about deep learning, you talk about sort of the holy trinity of having a lot of data available, and of having a lot of computing power available, and of having researchers and/or algorithms that can solve these problems. All of it was a big black box in the beginning, and actually on each of these columns, probably the GPU part of it, or the compute part of it, is less an issue, but I definitely changed my views on data, because you kind of approach this from the buzz of, you have big data, and then you realize that it's not actually about quantity as much as it is about the quality of the data. So that's kind of a simple but big learning. And
so let's talk about quality then of data. So what are the pieces that really make a difference? So first of all, what did you count within EyeEm, of data accuracy and the things that really made a difference for you guys?
So I think one thing is we were really lucky, I guess, because, maybe we had the foresight, because from day one we made sure to gather data, even though we weren't really sure what we were going to do with it or what we would be able to do with it. Every single photo that was uploaded to EyeEm obviously had location data. We made sure that the users or the photographers were tagging their content. We actually tagged on weather information. We tagged on camera information. All of the metadata was just extracted and stored with the sort of notion that one day we would be able to use that. And that was quite helpful, because I think a lot of companies, and we see that quite regularly, that companies reach out asking to buy data from us so that they can train models. Obviously, the industry has changed in the last few years, and you shouldn't be starting a company that tries to tell the difference between a cat and a dog anymore. But with time, the whole approach to data started changing, because for a bunch of reasons. One, a lot of companies were doing this similar thing. Two, you cannot really keep retraining these massive models and always have to source content. I mean, we're talking about a training set of 100 million photos, and once we realized, okay, we don't have
enough images of this table, so we can't really train it. We had to start to look at different techniques whereby we could teach a machine with a very limited data set to understand photos. But even more so, as we commercialized, customers that would come to us would say, you know, fine, you can tell what is a good photo and what is a bad photo, but our brand identity is different than the brand identity of a different partner. You know, one of our biggest customers is a consulting agency, and when they look for travel, they want photos of high rises and like industry and massive buildings. And another big customer is a travel company, and when they search for travel, they want photos of, you know, vast landscapes and people having a beautiful time. And suddenly you realize that this one model that you train just won't scale, and you can't retrain an entire neural network for every single customer. So we had to figure out ways to start working with smaller data sets and to sort of innovate a little bit on how we train these models to make it cost efficient and quick.
And when is a data set big enough?
I think it's big enough. But at this point, you know, we can personalize both in terms of teaching the machine to understand a new object or teaching a machine to understand a new aesthetic with a data set of, you know, something as small as 30 photos. So it's gotten to the point, and I think this is kind of this shift that is happening in terms of the techniques used as well, that you're no longer just building these, because effectively a lot of these deep learning models in my mind are just very efficient brute force models, right? You know, super complex and lots of smart people and smart algorithms, but effectively you're just throwing a whole bunch of data at a machine and telling it, this is what I'm trying to find out, and letting it work, you know, doing millions and millions of iterations until you get a point where you think the accuracy is good enough, or the trade-off between precision and recall is good enough. And the way things are evolving now is that you're trying to build models and algorithms that can operate in a sort of a semi-supervised or unsupervised fashion with the same parameters. And you want to take away, and I think this is kind of important as well moving forward, you want to a certain extent for established applications, you want to take away the research side of it, and you want to turn it into a much more engineerable problem. Because building AI companies, there's a big black box, which is, in my mind, quite incongruent with the VC and the funding model that we live in today, because it could work out in a week, it could work out in 4 months, and one of our stated missions early on was, how can we make this into a very deterministic problem? And one of the ways to do that was to reduce the reliance on massive data sets. And obviously, with massive data sets, another problem was the fact that we had to still clean them. I mean, they were quite well. But to give a simple example of the cat, because like cats are very important in computer vision, you know, assume you train a model that actually is trained on the data and photos that are tagged with cat, and then you want to evaluate it automatically and see if it's working well on another data set that comes from that same community. You cannot never be sure that that evaluation set is perfectly labeled. You can also never be sure that the training set is perfectly labeled. So it could be that half the photos are tagged with a cat and the other half aren't. And the algorithm suddenly realizes, oh, every photo tagged with cat, there's a tail that curves like that. And every photo that isn't, the tail is straight. And suddenly it starts, you know, it starts, you know, to overgeneralize one way or another, and or you know, every animal becomes a cat, or only curled tails become cats. So there are a lot of problems in that area.
So what were the key pieces of the labeled data that were incorrect, for instance, in the beginning? What were the key findings where you thought, okay, we had to clean this up, we didn't expect this?
Well, since we're talking about user-generated content, in a lot of ways, people use different terms to describe the same thing. In German, Kind is child. In English, kind is nice. So suddenly an algorithm was trying to define something as K-I-N-D, and you were getting photos of you know, an old lady being nice and a little child running around. So it's quite confusing in that sense.
How do you handle this? So you have to manually then replace it, or how do you handle this?
You know, one thing we did very early on was we used mTurk very heavily. So we used mechanical Turk to help with the evaluation and to help clean up. And we developed quite efficient techniques of identifying these things. We also trimmed the data sets heavily. Another big problem is sampling, because so if you have 10 million photos that you're using for your training set, and every single, or let's say half of them are tagged no people because there are no people in them, and the other half is tagged people, those two labels, those two tags become really, really dominant. And then everything that's on the long tail, which is actually the interesting stuff, gets lost in translation. And you can't build individual classifiers. So you have to start coming up with smart ways of sampling, smart ways of pulling data out. Luckily for us as well, if there's something that we totally have no info about, we could just reach out to our community. So we were able to actually run sort of content sourcing campaigns by turning them into photography missions and say we want photos of happy families on the beach, or we want photos of modern work environments, very abstract concepts, and people would deliver. And then it became an easy matter because we have these models that can train and learn on very, very small data sets. Became a simple function of curate 30, 40, 50 photos that fit that topic, and then we just train the classifier on the fly.
And I mean, your system is, I would say, fairly good at also saying what makes a good picture and what makes a bad one, right? How did you train this? So what did you use as a qualifier? Like votes, like how popular were the pictures? Yeah. How did you do this?
So I mean, when we started, obviously, what we tried or what we looked into, even pre-deep learning, was looking at sort of the compositional aspects of a photo. There are quite a few set of rules that tell you what is a good photo and what is a bad photo. But the fundamental rule of photography is that good photographers know what the rules are, great photographers know how to break them. And we realized that the algorithms were just returning very boring, technically sound but very boring images. And what we were looking for was that moment, right? The magic moment. Luckily, again, we've been doing this for 8 years, so we have years of content that was curated by our team. We have years of input from photographers that are liking, that are commenting, that are interacting. We have a lot of data from customers that are buying images from exhibitions. So we had a really massive training set, and we had a pretty big training set of bad content. And beyond that, it was obviously on lots of proprietary tech, but it was simply a matter of feeding that into the machine and finding the thresholds.
Yeah. So let's talk a bit about data bias.
Yeah.
So you hinted at it, but how do you guys handle this? I'm sure in the beginning you've encountered a bunch of things yourself. How do you handle this now? How's this evolved in the company?
Mm-hmm. Well, I mean, data bias, I think, is quite a big buzzword as well, and there are different kinds of biases that are inherent in systems like that. Probably everyone here at one point or another has heard of how the very early computer vision models were called racist because quite often they would tag black people with animal tags. And I won't be lying if I admit that at the very early beginnings we had the same problem. And it's not because our research team were racist and sitting in the back and going like, oh, monkey, monkey, monkey. It's not that. It's just that the systems haven't seen enough data. And that's probably the simplest kind of bias. I think the bigger problem with bias is that these machines, these algorithms effectively mimic our reality and do it at scale. So if you have police bias in some city against people of color, or if you have the banks being very, very strict in terms of who they give loan to, or biased against people of a certain socioeconomic background, and you try to train algorithms to work in that way, then you will basically take those biases and just amplify them. And that's a really big problem, right? And the question is how you handle it. You can't really effectively clean up every single data point. Do you work with synthetic data sets? Do you try to identify the individual cases and work with them? In our case, it was a little easier, obviously, because we could very quickly flag content, and then we could just personalize and retrain the models really efficiently. So we had people on our team that were helping out with that. And because the search is relatively powerful, once we find a couple of examples of what shouldn't be labeled as good or what shouldn't be labeled as bad, it was relatively easy to then source similar content from the data set and add those as extra weighted markers into the next iteration of the models.
Yeah. So the counter is brutal.
Whoa.
We have 1.5 minutes left. I want to try to squeeze in 2 questions. One, so based on data, like also your advice, what machine learning techniques can you choose based on the data you have, right? Like people talk a lot about what should they use and what techniques, but if you look at it from a data perspective, what would be your advice, like to try out?
It really depends on the outcome that you want in the end, and on the kind of data that you have initially. I mean, deep learning is kind of the de facto approach right now. Convolutional networks, where you throw a bunch of data and try to get something out of it. Reinforcement learning is super interesting as well, because you can simulate, like we were talking about. It generally depends on what you're trying to implement and what kind of data you have and what shape. But the way I see it, there's a trend now that is moving a little bit away from this holy trinity, which we talked about. I think more and more we're going to need less data, which is great because that means it's more accessible. More and more we're going to need less research and more engineering, which makes future ML products and future ML companies have the ability to build things without having to go into that research black box. And through the compression and things like that, you just need cheaper hardware and cheaper GPUs. So at this point, I think it's gone into the mainstream to the certain point that you can start really looking for problems, actual problems, and you should pretty much always be able to find enough data to build a solution for that.
So very quick, within 10 seconds, your advice to startups applying machine learning now. 10 seconds.
Don't build a company with the hope of just exiting because you do AI, because that's no longer the case and it's no longer that interesting. Find an actual problem. The techniques are there, the data is there, the hardware is there, it's cheap. You can actually build real solutions, and pretty much every industry that has existed for over 30 years is in need of these kind of services and these kind of solutions, and you can build a very, very good business by just doing that. So build an actual relevant solution and don't do the buzzword stuff.
I want to host more of this kind of data discussions with interesting founders like you. Guys, thanks so much. Give a big hand to Ramzi. And I think we have to go off the stage for some surprise.
Thanks, Mike.